Okay, so in this video I will discuss the product rule in calculus, and also how to solve something, particularly to find a tangent line to a specific point given a function and a point. I will do that first. So if we are given f of x, which is the same as y equals actually um, negative 2x cubed plus x squared minus 4x plus 3, and we're given points 1 and we are given negative 2. So in order to solve this, well, they're asking for a tangent line specific to this point. So a tangent line should be a familiar concept to you as well. The slope of a tangent line to any point is the derivative of that point. And so we're going to have to find the derivative of this function first, and then we'll apply point slope form and we will solve from there. Therefore, f prime of x, aka the derivative, well, what's the derivative of negative 2x to the third? Well, I think of it this way. We times the 3 by the negative 2. Gives us negative 6, right? And then we have minus 1 up on that exponent, which is squared. In other words, the negative 2 to the third, negative 2 times 3 is negative 6. Negative 6 x to the second, right? Because 3 minus 1 is 2. And then plus, well, what's the derivative of x squared? We'll take that 2, drag it down, minus 1. It is 2x. And then we just say minus 4. And we don't use this 3 over here. And now what we're going to do is apply point slope. Point slope is, well, actually before I apply point slope, I'm going to plug in this x into these x's. So negative 6 times 1 squared plus 2 times 1 minus 4 is equal to negative 8. I just want to check that real quick, make sure it's correct. 6 times 1 squared plus 2. Yes, negative 8. So we have negative 8. Well, since I plugged in x to that, that means that negative 8 should be the slope, which means that in the case of y equals mx plus b, you know your slope, that the slope is negative 8. In other words, what I'm going to do is clear this. If I do point slope form, y minus y1 is equal to m x minus x1. If you memorize this, your life will be instantly easier. Our y1, that was negative 2, correct? So that means y plus 2. Because negative times negative is equal to a positive, right? And we have the point 1 comma negative 2. And then our slope, that was negative 8, correct? And then x minus x1 minus 1. And so we have y plus 2 equals negative 8x plus 8. And then minus 2 on both sides. Y equals negative 8x plus 6. Now this is the equation tangent specific to that point. So if I had a graph of that, it would look something like, plug it into my calculator. That's 4x plus 3. the actual graph of that is something like this sort of thing. And then when I plug in, well, negative 8x plus 6, the line kind of goes like this. So, as you can see, it is tangent to that line, and therefore it is the derivative and the tangent line. In any case, let's try another. Let's say I have f of x equals x squared minus 4 at the point 3, 5. Okay, this is relatively easier than the last one. Well, we know the derivative of x squared is equal to 2x, right? Because I dragged that down, and that's 2, and then minus 1 is just, well, 2x. So, prime of x is equal to 2x, right? Because I don't need this 4, there's nothing attached to it. So then, plug that in. 2 times 3 is equal to 6. Which means our slope is 6, right? And I just plug it in. Y equals y1 minus y1 equals m x minus x1 point slope. And then, so that means y minus 5 is equal to 6 times x minus 3. Y minus 5, 6x minus 18. And then plus 5 plus 5. And then we get y equals 6x, and that's going to be minus 13 over there as the equation tangent to that. And let me show a graph. The line x squared minus 4, that will look something. Well, I know if this is 1, this is 2, and this is 3, and this is 4, then it has to be on that negative 4, right? Even if I factored, I could find that. And then it's going to go from here. So we're going to have these, it's going to look kind of like a curve that goes down to that 4, and then it goes kind of like that. That looks a little strange, but I know I'm not good at drawing. Anyway, you can probably picture in your mind what that would look like, or look on a calculator. And then we have 6x minus 13, and that goes right to that point. Our point was 3, 5. Well, 1, 2, 3, 1, 2, 3, 4, 5. That's a little up here. That should be up here, which this goes tangent right to it. Tangent, it should be touching over here. Okay, I cannot draw properly. We established that. So anyway, that is how you solve anything when they ask you to do a specific point. Let me do one more of that, and then we'll get to the product rule. Okay, I just want to do a more complex one to show you. 3 radical x minus 4. Oops. X minus 4 radical x minus 1 at the point 1, negative 2. Well, what's my approach to finding the derivative of this and this? Well, I know the power over root sort of rule that we established in earlier videos. So I know that the exponent that this x is carrying is to the first. I know up here we have this 3, so, and I have this 3 over here, so I'm going to do 3x Well, this is not the derivative yet. I'm just rewriting the equation. So 3x to the 1 over 3, because this is the inside over the outside, right? And then the same thing goes for here, except I know that the square root is naturally a 2, right? So 1, so negative 4x to 1 half. And then we have minus 1, and we're not going to really use that. So in other words, now we find the derivative of each individual. So 1/3 times 3, and also minus 1. 1/3 times 3 is equal to 1, right? So it's going to be x. And then minus 1 is negative 2 or 3. And then this times this. 1/2 times negative 4 is the same as dividing it by 2, which is negative 2. Then minus 1 is the same as taking the negative of 1/2, which is x to negative 1/2. And 1 divided by 2. And that is our derivative for there. So what do we do next? Well, we plug in this x value. That's 1, right? So 1 to the negative 2 over 3 minus 2 to the 1. 2 times 1 of negative 1/2. Almost forgot the 1/2. Is actually equal to negative 1. And then we plug into the point slope form. Minus y1 equals m x minus x1, right? We eventually get y plus 2 is equal to negative x plus 1. Subtract 2 on both sides. We get y is equal to negative x minus 1. I will not draw that one. I'm very bad at drawing, as we know. And that is how you found that. But enough with the finding the tangent line to a specific point. Now I will go over the product rule. Okay. So we have many different rules for solving derivatives and finding derivatives of certain things. We have the chain rule, we have product rule, we have quotient rules, we have all sorts of things. But I want to go with the product rule first. Product rule, right? And product is multiplication, right? So if they ask me to find a derivative, that's y equals 2x plus 1, and then times x squared minus 4. They're asking me to find the derivative of these products. Well, I know f of x then is equal to 2x plus 1, and g of x is equal to x squared minus 4, right? But the general rule is that in order to find f prime of x, you take f prime of x times g of x, and then you add that to f of x plus g prime of x. In other words, I find the derivative of both of these, and then I'm going to plug it into there, and there, and there. We say the derivative of 2x plus 1 is equal to 2, and then the derivative of x squared minus 4 is equal to 2x, so g prime of x equal 2x. And then we just plug in, and we're running out of time, so in the next video I will finish this problem. If not, finish it on your own. All you have to do is plug in the rest. If you have any comments or anything, subscribe. Feel free to ask any questions as well.